Hey class, this is Mr. Win here with a video for January 29th. This is Monday. The topic is linear equations and inequalities. Okay, so we're going to look at a word problem, and this is going to give us the context of the kind of problem that we want to set up. Okay, so let's look here. Suppose the managers of a shopping center want to upgrade their security system. Two providers bid for the job. Okay, so the first one is called Super Locks. They're going to charge $3,975 to install the equipment, and then $6 per day, remember that keyword per, to monitor the system and respond to alerts. Okay, so installing the equipment, that's a one-time thing, but $6 per day, we know that that's going to depend on how many days we're going to monitor the system, meaning that our X is going to go along with that 6. Okay. Okay, the other company, Failsafe, will charge $995 to install the equipment. Again, that's the one-time fee. And then we're going to add to that $17.95 per day. So that's where the X is going to go. To monitor the system and respond to alerts, both companies are reliable and capable, so the choice comes down to cost. Okay. The cost of the security services from Superlocks and Failsafe depends on the number of days the company provides service. The graph below shows the bids for both companies. So let's start by interpreting the problem in the graphs here. We want to use the graphs, okay, the graph is over here, to estimate the answers to these questions, and we want to explain our reasoning. Okay, for what number of days will the cost for the two companies be the same? Okay, remember that word the same means equal, right? So let's look here. We have a blue line and a red line. It actually doesn't tell you which one is which, but we can figure that out. Okay. So remember that Superlocks, the initial charge there is $3,975, even if you haven't had any days yet. If you're at 0 days, you should be at 3,975. And then for failsafe, we start at 995. Okay. Okay, so Superlocks, we're starting at 3,000 something, almost 4,000 right here. So the Superlocks one, that's the one that's in red. Superlocks. And the one that was in blue, that's failsafe, starting at like 900 something dollars. And each of these, they represent the cost depending on the number of days that we're using the system. So if we're using the system for 100 days, then for failsafe, it costs somewhere around that amount, which is almost 3,000. And for Superlocks, it costs somewhere around that amount, maybe around 4,500. Okay. Now, again, our first question number 1, it's asking what number of days will the cost for the two companies be the same? What that means is Superlocks is red, failsafe is blue. When the cost is the same is when those two lines intersect. Okay. Where the two lines intersect, we call that the point of intersection. We learned about that already. And we want to figure out how many days is that? Well, we just look down on our x-axis. Looks to be about in between 200 and 300. So I would say 250. And let's see if we can find the cost of that. The cost is on our y-axis. Okay, that's why it's labeled that way. Our cost looks to be about, well, if this is, maybe this one's 5,000. Okay. If this is 5,000, then right up here should be maybe 5,500. Okay. $5,500. So 250 days. 250 days. And $5,500 is the cost. Okay. All right, pause the video and go back and rewatch that if you didn't catch what we did there. We found the point of intersection, we found the x value, which was the number of days, and we found the cost, which was the y value. Okay. For what numbers of days will superlocks cost less than failsafe? Okay, we want to find when superlocks, the red graph, when is that going to be less than failsafe? Click on our graph again, and I'm going to erase this now. So if we're looking when superlocks is less than failsafe, when the red one is less than the blue one, that means we want to see where the red graph is below the blue graph. Okay. So if I look in this section, the red graph is actually above the blue graph. So the superlocks is not less than failsafe there. But in this area here, we have superlocks being lower than failsafe. Okay. That means the cost in that little section, the cost in that section should be less than the other company. And we can figure out what that interval is. So we start at our point of intersection there, again at 250, and then from 250 and on, superlock should be cheaper, it looks like. Okay, again, we're looking for where the graph that we want to be less than. If the cost is less, that means the graph is below the other graph. Okay. So it's going to be from 250 days and on. So 250 days, or we could say greater than 250 days. Okay, that's a sign for greater than. Okay, for what numbers of days will superlocks cost less than $6,000? Okay, so we're not comparing the two companies, but we're just looking at $6,000. So let's look where that is. Okay, so $6,000 is right here. Here's that line for when the cost is 6,000. We want to figure out when is superlocks less than 6,000, meaning when is our red graph below the line of $6,000. And we can figure that out. Right here it's below, right here it's below, 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 below. Right here is where it intersects. And then after that point, superlocks is now more expensive than $6,000. Okay. So again, our y value represents our cost, and we want to figure out how many days we can spend with this system to be less than $6,000. Well, any day from 0 all the way up to this point, which looks to be about, we could say maybe 340. Maybe 340 days. We're just estimating here based on the graph. So we're going to say, I should say less than, this is my less than sign, less than 340 days. Okay. Just as a reminder, the greater than sign, I'm not sure if my camera is going to be reflected here, but my greater than sign, the part when you read it from left to right, this is greater, like greater, and then gets smaller. The less than sign starts out small and it gets bigger, so that means that side is less than. Okay. What is the cost of 1 year of service from failsafe? So 1 year of service. Okay, let's look here. Failsafe is our graph in blue. And if we want to look at the cost after 1 year, remember that 1 year is 365 days. So right around there, that's about 365. Let's see where that intersects with our graph. And it's right about here. We want to figure out what that cost is. Our cost is our y value, so we look over on the y value. We see that it's about, well, this one would be 7,000. So if we go up a bit, let's say maybe $7,500. So about $7,500. The cost of 1 year. Okay. All right, feel free to pause the video and go back if you need to recap anything that we did here. You can go on to the next page. For each company, write an equation for the cost C for D days of security services. Okay, so let's start with one of the companies. Let's start with the Superlocks. Okay. Superlocks. You want to write an equation for the cost. Okay, the cost is C equals. And the variable we're going to use is D for the number of days. So let's look back real quick. Superlocks. Remember that was $3,975 to install the equipment. That's the one-time fee. And then $6 per day means $6 for every day that we're going to use that system. So that means our one-time fee again, $3,975 plus we add to the cost $6 for every day. So 6 times D or 6D. Secondly, here we have failsafe. Okay, our cost is going to equal that one-time fee plus the cost of each day, so $995 to install the equipment. Okay, and then we have $17.95 per day. Let's see if I can remember those numbers. I believe it was 995 plus 17, was it 25? 17.95, $17.95 per day means times the number of days D. If I have more days, then it's going to cost more.